Need you to find your packet, and I need you to find the simulation that we were working on with the World Series games. And if you are not here, you should cheat off of the person next to you to find the calculator command for that. Or cheat off of your teacher to find the calculator command for that. Great, how are you? I have a Vegas Mat update for you later. Vegas Mat update for you. Okay. Guys, if you just walked in, you're going to write this down later. But what I need you guys to do is find this. So if you were not here on Friday, we started working on this simulation. You can write this very quick. The calculator command that we put in ran is 1.7. The 1 is team 1 winning a World Series game. 2 is team 2 winning a World Series game. And 7 is how many games you play at maximum in a World Series. You want it to be 7 because you want to get your money's worth for your tickets, is the whole point of this simulation. So what I need you guys to do now is, if you did not do this calculator bit, you need to do it. And if you did do the calculator bit, you need to analyze your data here and figure out who won in how many games. Okay, so remember, it's the team to win, or who wins 4 the fastest. And when they get 4, that's how many games it was. Okay, let me say that again. It's the team to get to 4 wins the fastest. So mine was team 2, 4 wins, but it took them all the way to 7 games to get 4 wins. So you're going to write something like team 1 won in 5 games, or team 2 won in 6 games, or something like that. Did anybody have a sweep? Do you guys know what a sweep is? Like team 1 won all 4. Okay. Now what I need you to do is, after you analyze it, just take a 15-second check with your group. Put your results in the middle. Just make sure that you guys all agree that you guys all got the same, that you did it correctly. Because a lot of people are not baseball people. And they don't know what a best of 7 series is. Just take 20 seconds, talk it out. Yeah, I got it but it's kind of like a little like yeah, exactly. What, honey? Yeah, okay, so Cameron, being offspring of a teacher, understands that the sticky note means that now we're going to combine our data. So what I need you to do is take the sticky note, and because she freaking read my mind briefly, and you need to put how many games everyone got in your group. So if you could just put like 4, 5, 6, 7, however many games you're pushing. I'm gonna make it into a dot block. Anyway, all I need is the number of games. I don't need the team. Okay, so this group, these both had 7, so they're just gonna put 7, 7. Yeah.
You're making a face like this. It's just not.
Okay, so what I'm gonna do is I'm gonna take your data that your group gives me and make a dot plot for the class.
So how many games?
Just how many games? I just need to know, just list them. And then hand me your postie as I come by. Wait. Look at this group. I don't know. Wow. I love That means that the adults are making it not funny.
Oh, is that what the plan is? I think it is working.
Made everyone sick of it before I am.
Like they-
Yeah. Okay. So I'm gonna take all of your posties here and make a dot plot. However, I do not have time for you to analyze the dot plot. So just make this real quick. And then you're gonna grab your notebook again. And while you're setting up your notebook, I'm gonna analyze the dot plot and then we'll come back to this, but I don't have time to wait for you to write. So just make sure you have this. And then, what? I can, but I'm going to not have it up there. So it's on the video though, or you can look at my notebook at the end or whatever. Okay. You can see why I need you to, yeah, well, you just got to make this giant table. It's not hard. It's just. Okay, everybody. So I'm going to work on the dot plot and the statistics from the dot plot while you guys set this up. See, we're gonna use time wisely. I did not. I'm sort of freaking out about lack of time. Because we had the short day Friday, so I didn't get to finish the lesson, so I've.
It looks so scary.
Oh, my dot plot's a little wavy once you see it.
Which thing? So this is what I did. I went in 5 and then I said, okay, 2 spots, and then I did, so it's gonna be 1, 2, 3, 4, 5, 6, like rolling dice. So I did 2 spots for the label, and then I went 1, 2, 3, 4, 5, 6.
Are we gonna write something on the other side of it?
No. We're gonna write one tiny thing right here.
What's the bottom of the slide?
Bottom of the table, yes. Bottom of the notes, sadly, no. Okay, just for fun, I'm going to pass around. I want you guys to play with for a second. I have a loaded dice. So this dice is weighted on one side. Just roll it in your group a couple of times, see if you can figure out what side is loaded to. Which means what side will come up more often. Not yet, not yet. You're right. You
No,
can't.
no, but like when we do.
Yeah, so it's gonna look like this. So I'm gonna write what I get from the first dice, what I get from the second dice, and then the sum.
Okay. I can write four.
Oh my God, this job, this gal, yeah.
Actually, a student bought that for me. She also bought me all of these
Wow.
D&D stuff, yeah, but it's fun for probability. She got me green ones and purple ones and okay, guys, shh. Okay. So where are you at with your table? You look like you need 60 more seconds. What do you guys think it's loaded to? You're saying the same thing.
Oh, yeah.
The heavy side is the 1, but it makes the 6 roll more often. They're not cheap. The dice. Oh, dang.
You can bring your own dice. Yeah.
Oh, Callie and Mariana, I have a funny dice story for you two later. Just remind me later. Trust me. Okay. So go back to here. Just gonna take a second to finish this up. Okay, so I did all of this while you guys were setting up your page. So there's 3 dots in the 4 column. 3 dots in the 4 column. There's 7 dots in the 5 column. 7 dots in the 6 column. And 8 dots in the 7 column. So it goes 3, 7, 7, 8 for the heights. Okay, now what I want you to do is circle, don't circle this one unless you got 7. Just circle wherever yours was. If you got 4, 5, 6, or 7 for your trial. Just do the top one. It doesn't matter which one. You guys both, one of you got 6, one of you got 7. I don't know. Okay, and your dot represents my dot is 1 simulated trial. Where it took 7 games. Don't put 7 unless you got 7. And what I really want to express to you here is that simulation is really handy, but it's really lazy. Like, this is basically just how do I do a bunch of math and ask a bunch of questions and find out a bunch of stuff myself without having to ask anybody or do any research or anything. Simulations are not perfect, but they can give you a good idea. So the average for our class was 5.8 games. That means that this dude, whoever bought these tickets, is likely to be able to go to 6 of the 7 games. So he might make that decision about whether or not it's worth it to buy the tickets based off of that. You see what I mean? Like, it helps you make decisions, but it's kind of lazy because it's like we're just using a calculator or dice or a coin. Okay, last, use your dot plot to calculate the approximate probability that the fan will get to go to all 7 games. Okay, so we write capital P. And this is the first time we're going to use this notation, but capital P, when you see that with parentheses, you say the probability that he gets to go to all 7 games is 8 out of 25. And there's 8 in this column, 25 dots total. That's where I got that. Nope, everyone got 8 out of, so it's just the height, it's how many 7s out of the total.
Oh, I see.
Okay, and now you're done with your simulation. So you can scooch that all off to the side. Okay. Sample space. The most annoying thing in probability, a list of all possible outcomes in a chance process. Sample space is a list. It's a list. It could be a big list. Every possible thing that could happen is a sample space. Now the example, I picked the smallest one I could think of. So tossing one coin, the sample space would be heads and tails. That would be it. I tried to think of not the most easy, tried to think about, okay, 2 coins. And there's a reason that I wanted to bring this up, but I could get heads and heads. I could get heads and tails. I could get tails and heads. Or I could get pie. No, it's tails and I made it look like a pie. Okay, what's the sample space for this guy here? 1, 2, 3, 4, 5, 6. What's the sample space for this guy here? There's a 0, 0 though, fun enough. 0, 0, 10, 20, all the way to 90. Okay, and the reason they do the 0, 0, and this is really great for us, is they want all of the digits to be the same length. So instead of 100, they use 0, 0. So you can fit all the numbers are the same size. Or it's some kind of rule in Dungeons and Dragons, I don't know. 0, 0 must be something. What about this guy here? Yeah, 1 through 20. Okay, so when you're rolling 2 dice, it gets complicated. The first dice, you could get any of those options. Shh. And for the second dice, you could get the same options. And a lot of times, so we're going to set up the sample space because I know in your homework, you're going to need this. A lot of times what you do is you roll 2 dice and add the numbers that you get. So this would be a sample space representing the sum of 2 rolls. But what we're going to do is we're going to put what each one would be. So up in this corner, I'm going to get what I rolled. So ignoring this, all of these boxes, I rolled a 1 in die 1. All of these boxes, I rolled a 2 with die 1. And then you just want to be done with sample space already. Sometimes it's the only way though. Just list everything out. Why am I struggling with writing numbers on Monday, Tuesday? Oh my God, I don't even know what day it is. So, fun gambling fact. I don't know anything about craps. I don't know how to play it. I got nothing. I don't even know. I've got nothing. I know that the probability of winning is ridiculous and I just don't touch it with a 10-foot pole, basically. It's just like walk away. But this is the feeling I get. Okay, so Theo, what I'm doing is I'm adding. So in this box, I rolled a 1 and a 1. So imagine, here's my visual. So this represents this roll here. I rolled a 1 and a 1, and I add the 2 and get a 2. Okay, in this box, I rolled a 2 with my first dice and a 1 with my second dice, and I add them to get a 3. Do you need to add them in every case? No, it's just a very common thing to do is to roll 2 dice and add the numbers together. A as rolling. Okay, so while you're waiting for us, count how many boxes in your sample space get a sum of 5. 4, perfect. Okay, here we go. Event. Any outcome or combination of outcomes. So I might define event A as rolling a 5. I might define event A as rolling a 5 or a 7. I might define it as rolling a 1 on the first dice. But it's anything that I want any combination of outcomes or any outcome. Shh. And this is important that you are interested in. So what's the actual problem asking? And I'm going to use this language a lot. What am I interested in over the total? So that's basically the definition of theoretical probability for us when calculating probability. It's what you're interested in over the total. In this case, it said 5. How many 5s were there? You counted 4 boxes, right? Over how many total outcomes? And the problem with this is I expect people to come into stats with a basic knowledge of probability, except for we've cut it out of almost every single math unit in high school. I know they do some in elementary school, like basic stuff. But we have to start from scratch. So, and another thing is I need to teach you guys notation. So when you read this, you need to say to yourself, what's the probability of event A? But we're too lazy to write out what's the probability of event A. So we just write capital P of A, basically. So the probability of A is the number of 5s over the total number of outcomes. I know this is probably in your brain somewhere, right? What you want over the total, like, does that live in your brain already as basic probability knowledge? Okay, so there were 4 ways you could get a 5 over 36 total outcomes. Does the 36 make sense to you guys? And we're just going to leave it like that. You can do a fraction, a decimal, a percent for these. It doesn't matter. Anything you want, unless it says specifically. Any questions about where I got 4 and 36 from? I really need to make sure you guys are clear on that. There were 4 boxes that had a sum of 5, 36 total boxes. Okay. Okay, now none of us really like to make a sample space when there's a lot of options. I don't either. So what I will end up doing is condensing my work into a probability model. Also big in this problem. If you're wondering how long this is, it's all of the possibilities that we rolled. So this would be 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, goes to 12, right? 6 plus 6? Yeah. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of the different possible sums that you can get when you roll the 2 dice. I actually typed into ChatGPT earlier before I went to Reno. What is the probability model for American roulette? You guys know that there's 2 different types of roulette. There's American roulette and European roulette. Do you guys know what roulette is?
Yeah.
It's the wheel with the ball. That's super fun to watch. Just go like me. But everyone doesn't take into account the green spaces is the problem with roulette. Like you think you know it, you think it's 50-50, but it's not because of the green. Can't forget the green. Mrs. Talbot, I forgot about the green. No, I did not play roulette. What are you asking me about? Okay, I have questions. While you're doing this, how many cards are in a deck of cards? Not the jokers, don't include those. 52. What are the suits?
What is it?
Oh, no. Club, heart, diamond.
Horseshoes. Sorry, I was on the Lucky Charms. No, it's good.
What is
Okay.
it? Triangle.
So what's the probability of getting a heart? 1/4. Yep, good job. Okay, what's the probability of getting a 2? Don't reduce the fraction, just give me the, there's, yeah, a 2 out of the whole deck. 4 out of 52, good job. Okay, what's the probability of getting a king? What's the probability of getting a black card?
One half.
26 out of 52, yeah. Okay, hardest question. What's the probability of getting a face card?
Right now.
12. Yeah, there's just Jack, Queens, and Kings. Those are the only ones with faces. Okay, anyway. That's supposed to be a 1. Okay. All right, so probability model has very strict rules. It has to have all possible outcomes. For us, we're going to do the sum. So we're going to talk about the sum of adding the 2 dice together. And all of the probabilities, so this is the outcome. This is the probability of the outcome. That's how you read it. And then all of the probabilities have to be fractions or decimals. And they all have to add to 1 because that covers your whole sample space. Does that make sense logically to you? All options have to be covered, so all probabilities have to add to 100%. Okay, so in our big giant thing we made, we could roll a 2, right? If you get a 1 and a 1, you could roll a 3, a 4, a 5, 6, 7, 8, 9, 10, 11, and 12. That would be the top if you rolled a 6 and a 6. So this is rolling a 1 and a 1. This is rolling a 6 and a 6. And this is everything between. Okay, so all we're going to do is just count boxes. So how many boxes were you able to get a 2 when you rolled? 1. So 1 out of 36. Do you guys see what we're doing? Okay, and these are easy because they kind of go diagonal. So the 3s were 2 out of 36. We're not reducing or anything. We don't care about any of that. Actually, this is better because you can really see the number and how many possibilities there were. This is the one we calculated a minute ago. How many boxes were 5s? Okay, and then it maxes out at 6. That's like down the diagonal of our sample space. Okay, when you're ready, flip your page over. Just so you know, there's 5 bullet points here. Okay, let's talk about 5 basic things, very, very basic things you need to know about probability. The first is the actual definition of probability. So what you're interested in over the total is basically what I need you to read here. So you're going to read the probability of event A is all of the times A happens over the total number of outcomes. So A over the total. I know this is very basic, but I don't know what knowledge people have of probability walking in here because I don't teach any of it in math 1 or math. I don't teach math 2. I don't know that it's in there. And then math 3 doesn't have any, so I don't even know. Okay. All possible outcomes of a random chance process add to a probability of 1. And you need to know this. You need to trust in this because it will make your life easier in a second. All probabilities should be between 0 and 1. If you leave a test with a probability over 1, I'm going to be sad as I'm grading because you should know that's not possible. Okay, now this is new stuff. The complement rule. Okay, do you guys know what complementary means in trig? Means like adds to 90, right? Okay, so the complement is everything else, basically. The complement rule in probability is everything else. This is notation that says probability of A complement. What I want you to read is the probability of not A. Everything else. There's a lot of notation to learn. This is the symbol for not in AP Stats. And it means complement. And it means everything else. So you just do 1 minus because you want everything else. Okay, now this is your buzzword for today. If you want to go home and tell your people there what you learned today at school, tell them you learned about mutual exclusivity and they will go away and leave you alone because it's scary sounding and they don't want to have to know anything about it. But it just means they don't overlap. Okay, here's another new symbol. This is called the union symbol. And it means or. So when you read this, you're going to say the probability of A or B is the probability of A plus the probability of B. This only works if they're mutually exclusive, which means they don't overlap. Okay, like, let me say, like tossing a coin and rolling a dice. Those are mutually exclusive events because you can't get a heads on a dice. Okay, does anybody know what this symbol probably means then? Yes, nice. Okay, and I like to remember, so this is how I remember these. I like to think of this as an A that just doesn't have a line in there, and then it shows me that's and, because and starts with the letter A. Okay, again, this looks like an A that somebody forgot to put the line across. So that's how you know it's and then or is just the other one, the flip. But it's really, the symbols are actually defined in an opposite way. U is for union, and then intersection is not union, it's the opposite. But anyway. Just, the bar across the A thing will work the whole time, because there's really only the two. Okay, and then I want you to draw me a little picture over here. What do you know about this here? Do you know what this is? Does anybody know what this is? It starts with a V and ends with an N. Venn diagram. It's called a Venn diagram. You've never heard of a Venn diagram before? Venn, V-E-N-N. Okay, not always. No, notice what my definition says. What does this say? That is a very special Venn diagram when there's mutual exclusivity. Okay, now I'm going to move this paper. There is an example. You're going to groan loudly. Get ready. Verbal groan. I didn't hear it. I'm sorry. There you go. Thank you. Well, you're going to have to go speedy fast. You didn't mean there was going to actually be work in this class. I know. For shame. Milligrams per deciliter. It's milligrams per deciliter. It is. it's a very vertical slash for some reason. Okay, I just need you to finish writing this, and then I'll do this very quickly at the start of Friday. So just, it's extremely easy. You could do it yourself probably, but if you want to leave it for me, I can do this at the start of Friday. But just to fill you in, why are they mutually exclusive? Because there's no overlap between greater than 240 and between 200 and 240. Those two things don't have any overlap, that's why they're mutually exclusive. Probability of A or B, you just add them together. And then probability of less than 200 is everything else. So then you just subtract from one, the answer you got. It's very easy, but just throwing that out there. Now, what do you have tomorrow? Got it. Okay, and so will I be checking any homework tomorrow? Definitely not. Don't do this. Don't do this. Don't do this. I mean, do it later, but not immediately. No card first and things. Studying, refamiliarizing with chapter 4. Oh, thanks. Isn't it fun? It's really fun. Well, I mean,
Let me try. You're a little social, right?